Welcome to COP326, getting actionable insights from Amazon CloudWatch logs. My name is Bobby Hallahan, and I'm a senior specialist SA with the observability team at AWS.
And my name is Nikhil Devan. I'm a senior manager of product management for CloudWatch logs.
Awesome, thank you. And in this session, it's going to be all about, like the title says, right, getting actionable insights. But when we think of like what's an insight and actionable, right, it's something of value, right? So something I talk to and speak to customers all the time is how do we get the most value from our logs? Things that may already be in our log groups, or if we're looking at bringing in new workloads, how do we get the most value out of logs and maximize how we're already using CloudWatch today? And that's going to be a lot of what our session's about. But for the agenda, let's take a look at first where we'll kind of start off at. This is a 300-level session, so there's going to be some assumed knowledge that you have working knowledge of CloudWatch. You know some basic stuff about observability. You're familiar with the platform. But if you're not super familiar, that's fine too, because we are going to do a quick overview, a quick level set on what observability is. I promise I'll keep it pretty short, and then we can move on to the really cool stuff. From there, we're going to go into a launch of like what all the new stuff we launched this week. So really, really cool launches. If you look at the What's New page from Sunday, I think there's like 3 or 4 really, really neat launches with CloudWatch logs. From there, we'll talk about how we can use those new features, as well as all the existing features in CloudWatch logs, to gain actionable insights from your logs. So with that, we're going to go ahead and jump right into an overview of observability. And really where I want to start is asking you all a question. And that is, how do you understand the health of your workload? Specifically, when we look at this, we want to think about a workload you own, a workload you support. Maybe it's a application that recently had impacted performance, right? Maybe something where there was some sort of large-scale event. Maybe you had extended mean time to investigate. And think of it from a different perspective, right? If you're an SRE or DevOps engineer, maybe you're a product owner, a line of business owner, think of that application and keep that in mind as we start going through these features. Because what we want to talk about, and what I want you to walk away with today, is the ability to be able to use these features in a meaningful and impactful way. And we believe that you should be able to. That is, if we don't mess up. Alrighty, so let's get some basic definitions out of the way. Let's talk about observability. Observability means a lot of things to a lot of different people. So you ask 10 people for definitions on observability, you'll probably get 10 different answers. The reason why I like this one is it's pretty grounded and it's pretty down to earth, right? So in control theory, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. So what do we mean by that? Well, we think of an internal system as your application. External outputs, that's telemetry, right? So you're outputting log, metric, and trace telemetry. Now, you want to think of observability as like 2 parts, right? So part of it's instrumentation, and then the other part of it is how do you use those output signals? How do you use that telemetry in a way that can be correlated with? So you can think of observability as a property of a workload, right? It has properties that make it observable. It's not just emitting log, metric, and trace data, but it's emitting it in a way in which you can use correlation. So in that same regard, you can think of observability just like other properties of workloads, things that make them highly available, fault tolerant, loosely coupled, or scalable, loosely coupled, and of course, observable. Now, we talked about that output signals, right? So you have log, metric, and trace data. And the reason why we have this in a circle here is because all these data types and telemetry types don't stand on their own, right? Being able to use them all in a single place, being able to go from log data, going from your trace to log correlation, right? Being able to view metrics and traces and logs in a single place, that's really where the value of observability comes into play, right? You don't lose context. You're all in a single tool. You can go from, let's find a metric that errors out, maybe causes an alarm. You're able to go to a service map, find specific requests that failed, and then find the logs for that specific request, right? At its core, that's a big part of observability. So with that being said, and hopefully this serves as a good intro and prep to observability, I'm going to pass it off to my good friend Nikhil, who's going to walk us through a little bit into CloudWatch logs and the evolution of the service.
All right, thank you so much, Bobby. So let's talk briefly about the evolution of Amazon CloudWatch and our logging solution, CloudWatch logs. So Amazon CloudWatch is the native monitoring and observability service for AWS. It offers a suite of capabilities ranging from agents that help you collect the telemetry and send them to CloudWatch, to core search and analytics for your 3 pillars of observability, as Bobby just mentioned, metrics, logs, and traces. Our recent focus has been around giving you out-of-the-box insights and powerful tools for you to dive deep, and interact with your data. And we're going to spend majority of the time today diving into these capabilities. What I want to stress upon you is CloudWatch is all about observability at scale. We have millions of AWS customers using our product, sending us 11 quadrillion metric observations per month. That's 11, followed by 15 zeros of metric observations per month, and 6 exabytes of logs ingested per month. That's 6, followed by 9 zeros of gigabytes per month. So we really pride ourselves at the scale at which we help our customers operate. So what do customers really like about CloudWatch? They like the fact that it's fully managed. It comes with your AWS account. There is no setup or management needed. It's highly secure, highly scalable. It has deep integrations with over 100 plus AWS services. What customers really like about CloudWatch is and that they can treat it as their home of telemetry, not just for their telemetry from AWS services, such as VPCs or Route 53s or Lambdas, but also for their metrics, logs, and traces from their custom applications. Customers love the out-of-the-box insights, be it automatic dashboards that help you surface key metrics for your AWS services, or curated experiences like containers or Lambda insights that help you not only automatically collect all the critical telemetry, but then visualize them in a manner where you can make sense and get actionable insights from the same. Finally, customers really value our investments in analytics that are aiding you in getting more actionable insights, the title of today's talk. Alrighty, so let's talk a little bit about CloudWatch Logs, which is the focus of today's session. It's an integral part of the CloudWatch service, and it was launched back in 2014. Back then, we provided a dedicated logging agent. We offered fully managed ingest and storage, and we had metric filters, which is the ability for you to create metrics from your logs and alarms on them. We've come a long way since our inception. And over the last 10 years, we have launched over 150 features for the CloudWatch Logs service. And don't worry, this is not a history lesson, but I'm going to touch on a few key milestones along our journey so far. So really, 2018, in my opinion, was a pivotal year for CloudWatch because we launched CloudWatch Logs Insights. It's a purpose-built, fast, interactive query engine that allows you to analyze your logs. What customers told us is that they love the ability to quickly gather answers from their logs and start their troubleshooting journey. And this is when I believe we really started transitioning from being viewed primarily as a logs management service to a more holistic logging solution, which offered not just core log management, but also core analytical capabilities. In the years to come, we have continued to invest in helping you get actionable insights from your logs. For example, in 2019, we launched embedded metric format powered by structured logging, as well as contributor insights. And we'll talk a little bit more about these features in the slides to come. But at a super high level, they help you ingest and analyze high cardinality data in the form of structured logs. In the last couple of years, we've actually further accelerated our feature velocity. Last reInvent, we launched cross-account log analytics that enables you to query logs across multiple accounts from a central monitoring account without having to duplicate your logs. We also launched sensitive data protection that helps you detect and mask sensitive information such as PII in your logs. 2023 has already been a strong year of feature releases for our service. Earlier this year, we launched Lifetail, that's tail minus F for those of you who are familiar with it, and several enhancements to our EMF as well as our Log Insights platform, such as launching 3 new query commands and higher overall limits for the query experience. And finally, we also launched support for account-level enablement of sensitive data protection. Now, what I'm really excited to share is that this reInvent, we are adding 3 new amazing capabilities that help you get even more value from your logs. But before I dive into these features, I want to start by highlighting some of the challenges or some of the types of challenges that customers have been telling us that they face with logging solutions today. So as you scale your applications, not only the volume, but the associated cost of logging continues to grow. Moreover, logs are not a one-size-fits-all. Different logs have different values for customers. For example, your critical application logs are not equal to your debug logs. customers want the ability to make the cost and feature trade-offs depending on their logging use cases. So what do customers do today? They either intentionally limit the amount of logs that they're collecting, or they drop them, the non-critical logs, which hinders their visibility. Or they split their logs across multiple solutions to manage their costs, leading to inefficiencies in the troubleshooting workflows. So I'm really, really pleased to announce that this re:Invent, we have launched a new log class called CloudWatch Logs Infrequent Access. With it, you get core logging capabilities that's fully managed ingest, storage, encryption, as well as the familiar query experience through CloudWatch Log Insights that customers have learned to love. We are offering logs infrequent access at 50% lower cost to the existing standard log class. How does one get started, you may ask? All you really need to do is select logs infrequent access as the log class when you create a new log group, and you can point your logs to it. Now, how do the features of infrequent access compare to the standard log class? Like I mentioned, infrequent access is really about those core logging capabilities, versus standard log class offers a full suite of log analytics, be it live tail, metric extraction and alarming on it, sensitive data protection, contributor insights, and a couple of features that I'm going to talk ahead in the presentation. So which log class should you really choose? So if you have your critical application logs that need real-time operational visibility, and you need those advanced analytics, standard log class is likely still your best bet. If you only infrequently access your logs, and you mostly need it for like after-the-fact compliance analysis, you're storing it after-the-fact forensic analysis, or you're storing it for compliance, the core logging capabilities of the infrequent access log class is likely going to meet your needs. Now, standard logs are available at 50 cents a gig in USD East 1, and infrequent access are half the price at 25 cents a gig. Now, it's really important to note that there are certain log types that are vended from AWS services like VPC flow logs, Route 53 logs, EKS audit logs. These are termed as vended logs. And for these logs, you already get volume-tiered pricing, ranging from 50 cents going all the way down to 5 cents, even in the standard log class. However, now, with logs infrequent access, we are reducing the entry cost for even vended logs. So they will now start at 25 cents a gig. So really, to summarize, CloudWatch Logs Infrequent Access enables you to centralize and consolidate all your logs within one solution, CloudWatch Logs. It helps you improve your visibility about your application health and helps support that after-the-fact forensic analysis that you often need from your logs. By enabling you to make these cost and feature trade-offs, we are enabling you to get more value from your logs. Our early adopters include Fluent Commerce and Design Crowd, who are cost-effectively scaling and consolidating all their logs in the CloudWatch Logs service. So let's talk about a few challenges that customers face with log analytics. Now, with an ever-increasing volume of logs, customers tell us that they find it hard to know where exactly to start their investigation and answer the very fundamental question: what changed? My application was running really well yesterday, and today it's broken. Just tell me what changed. Customers also want to be proactively notified of potential issues that are brewing. And it's even harder to predict the unknown unknowns that you did not even know that you were expected to monitor. So to illustrate this concept further, consider the analogy of Lego blocks. So I'm a proud parent of 2 boys, and they absolutely love their Legos. So my wife and I, we try our best to make them clean up after playtime. Unfortunately, what this means is that next day, we basically come to this at the start of the play session. So when my boys ask me, "Dad, can you help me find a block of a specific color or a shape?" we're basically scrambling and scratching our heads. It's at times like this that I wish I had a magic wand to just quickly sort and arrange these blocks by colors in those set of white boxes that I have bought for that very purpose. Now bear with me, you'll see where I'm going with this. Coming back to the world of logs, this is what your typical logs look like. Some would call this a wall of text. So let's look at any one line, right? So it has an info field, a timestamp, some dynamic identifier, API request received, customer ID, some dynamic pattern, right? But I can actually see a pattern emerging. So what if we compressed all of these logs into a single pattern? This pattern has a few static words, such as info, API request received, customer ID, and then it has a few star marks, which are what we are calling tokens that represent dynamic values. Some folks actually like to call that noise, because all they want to know is, how do I get from all of those logs to meaningful insights for me to know where to start my analysis? So with that, let's talk about the first new machine learning-powered analytics capability we have launched this reInvent. It's called pattern analytics. So now, anytime you want to go run a query, CloudWatch logs automatically surfaces the key patterns in your query results. So similar to organizing the blocks by color, this feature really helps you synthesize those thousands of log entries into a few critical patterns that can help you kickstart your investigation. As an example, in this query, you can actually see a few key patterns in your logs. And we are also telling you how often they're occurring through the event count and event ratio field, as well as the severity type, right? So the pattern with the word error is likely a good place for you to start investigating what's going wrong. So this is awesome. I've now got my blocks neatly organized in a few easy-to-distinguish patterns. So I leave the room for an hour, and I come back, and I find a new box or a pattern. And I can easily see what has changed. So again, let's apply this to a logs example. Here's another wall of logs. But now that we have learned about patterns, it's actually much easier to read. You're probably already doing this in your head. So we have clustered all of these logs into 3 patterns that I show on the screen out here. But then something changes. Did anyone catch what changed? Yep, so some of you have said it. So you are our pattern detector. But using the concept of patterns, you can now see that a new one has emerged. Now, if I compare this current set of patterns to the previous ones, I can see exactly what has changed. I started having errors related to my database transactions. So this brings me to our second awesome machine learning-powered capability we have launched this reInvent. It's called comparison analysis. So looking at this snapshot, I can see a new pattern has emerged, how often it's coming. And again, that's a great place to start to figure out what changed in your application. By the way, you should notice at the bottom of that snapshot, we also have a neat histogram that enables you to visually compare how a specific pattern trends over 2 time periods. That's pretty cool. So these are 2 really awesome features that our beta customers were loving a lot. And it got us thinking. Well, similar to how like a sorting tray in a fruit factory automatically filters out the outliers, what if we combined these 2 capabilities and also did not require you as customers to even run the query, but we instead just did it for you? And that's what brings us to our third, and what I believe is maybe one of our most powerful ML-powered features, always-on logs anomaly detection. So it's as simple as enabling this capability on your log group. And after that, CloudWatch logs will constantly evaluate your incoming logs against historical baselines, and you will be notified of anomalous trends that point to potentially emerging issues in your application. So look at the snapshot. We show you the logs anomalies view with key trends, key patterns. We also show you other details, such as the priority, which is at a high, medium, low, like how important is this anomaly, as well as the last detection time. There are other cool things on this view that I'm not able to show, which Bobby will demonstrate in his demo. So just to summarize, we have launched 3 really awesome machine learning-powered log analytical capabilities that I believe will completely change the way you interact with your logs. The first 2 require you to run a log insights query. So the pattern mode, which clusters your logs into a few critical patterns to aid your investigations. The compare mode, that helps you answer that very fundamental question: what changed in my application? And finally, always-on logs anomaly detection, where we analyze your incoming logs and proactively notify you of emerging issues. Now, last but not the least, I had talked about 3 capabilities that we're launching this reInvent. And this is another one which is really, really exciting. So we are pleased to announce today Gen AI-powered natural language query generation for logs and metric insights. Now we know that you value our query tools for the ability to just support these fast interactive drill downs into your telemetry. But we also appreciate that it takes some time as well as domain knowledge for you to learn and ramp up on our query syntax. With this launch, we have made it really, really easy for you to get started. You can literally ask a question in natural language, and we will generate the query for you. In addition, we will also give you a line-by-line explanation of what this query is, so that you can actually learn and master the syntax. And finally, using natural language prompts, you can also modify your existing queries for iterative deep dives, which is something we all do when you're using Log Insights. So this feature has been launched in preview in 2 regions, US East Virginia and US West Oregon, for the standard log class. And with that, I'll hand it over to Bobby to show you all of these features in action.
All right, thank you. OK, so let's go ahead and jump right into some features here. OK, so I think really it's best to be able to show this within the context of an application, right? So we can talk about features all day, but let's look at it in a real-world setting. So if you've ever used our One Observability workshop before, this architecture will be familiar to you, but if not, that's fine, because we're going to go through it really quickly here. Essentially, what we're looking at is a pet adoption website. This pet adoption website is a microservice-based application that has a few different front ends. You'll see that it has APIs for like list adoption, pay for adoption. And as we can see in the site, we can go ahead and do some simple things like search for a different type of pet, and then look to adopt a pet. And then from there, we can return home. And of course, errors are built in because it's a workshop, so there's going to be some errors built in there for us. So then returning to the site, we can see we just have these different APIs available to us. But really what we're going to try to hone in on is this search API, and we're going to look at that list adoptions API and see how we can get some value out of those logs. So let's go ahead and jump into the log groups here. And you can see I've enabled anomaly detection on that ECS pet search, list, and pay for adoptions log groups. So just in the log group, we go in and hit enable anomaly detection. From there, we can actually jump right into the log anomalies right there on the left-hand panel. And this is actually going to start loading up all of the log anomalies that it's found so far for us. So it finds the list of anomalies, the priority, this time, the log pattern, so the pattern of the anomalous behavior, anomaly trend, last and first detection time, along with the log group. And then more importantly, you'll see on the very right-hand side there if the finding was accurate or not, so we can provide feedback for the model. But let's go ahead and take a look at this first pattern. So here we can see it looks like there's some errors while searching and building the results. Exception, access denied, service, S3, or Amazon. And here we can see the different token values. So we can see log samples. So we'll pull in samples of that specific logs that met that anomalous behavior. And then here we can see the different tokens. So if I actually click the token, token 10 shows Amazon S3. So we're pretty sure these are S3 access denied errors. And with that thinking, I could say, I know S3 bucket level actions and service level operations are logged in CloudTrail. So maybe it may be prudent of me to go ahead and think about, how about we could just go to Logs Insights in CloudTrail, and we can kind of figure out what's going on from there. So here we are in the CloudTrail console. We have our CloudTrail log group selected in the region which we have logs written. But let's say I don't know Logs Insights that well, right? Maybe I don't know pipe delimited query language. Maybe I don't know the commands super well, right? Let's say I don't even know where to start. I don't have saved queries, and maybe this is something that's time sensitive. I myself have personally been in this situation a couple times earlier in my career before I focused a lot on logs, and it was, it's challenging. It can be stressful. And that's where we think Query Assist and Query Generator is going to be incredibly valuable, because now we can ask in a very plain language way what we're going to look for. So let's give it a shot where we just say, hey, let's find some S3 errors. And with that, we'll go ahead and generate the query. And if we take a look at the query, you'll see it's filter event source Amazon S3 and is present. So right there, I just learned how I can use filter fields and other command fields where I'm looking for a specific field name. We can include preferences to give that options to give us the comments of how the query is built. And then more importantly, you'll also see when we look at discovered fields, right? So Query Generator is using the context of the log group selected. So that's how it's able to then derive which fields to start selecting, meaning that based on the log groups you're using, you're going to get different results of the query, right? So if I just pick some log group where we don't have any field detection, it's going to do its best to give us parsing on the messages. But where we do have that type of field detection, it's going to be able to use those specific fields. And let's go ahead and run this query and see what we get. So here, it's like a wall of text, right? A lot of access denied errors. So we know that there are errors here, but maybe this isn't exactly what we're looking for, right? So let's use query generator to give us an updated query. So we can use query gen and have it update the query for us. So instead of, let's maybe org group it by the results by event name, right? So we want to know the type of event that's been used, and then the session issuer username. So that would be the IAM role or the person that actually called that session. So we can update the query. And then what we'll see here is now, since I toggled that description, we have the description there available for us. But also, we have an added new stats command. So now I know how to do statistical aggregation. And we can have stats as hits by event name. So I'm starting to be able to learn the language. And that's a big part of Query Assist. It's not only helping you build these queries, but it can help you iterate and learn the language as well. So now if we run this query, let's see what we get. And here we can see we have a couple errors for like AWS service role for config, but it looks like the big one here is event names create bucket. And it looks like that service role is from our search service API. And the number of times was 359 times for create bucket. Normally, I could probably say this is one of two things. One, it's probably an IAM permission error, maybe. Like maybe it needs permissions to create buckets, or probably and what's more likely is our service shouldn't be trying to create that many S3 buckets in the first place, because we're looking at a 1 hour time period. 300 S3 buckets in a 1 hour period is pretty ridiculous. So my best bet says that there's probably a bug in my application code where instead of creating S3 buckets, maybe it should have been creating S3 objects. And that's something I would look at. So there is a really great example where we're able to take a finding from always-on anomaly detection and then leverage logs insights without having any previous knowledge of how the query language works. And this is pretty much to go to show like where we can start using this in the real world, right? You see those anomalies, you can jump to the log groups, jump to logs insights and start using it. But now let's take a look at a different log group. Let's take a look at our pet search or pet list adoptions API. So we see ECS pet list adoptions. And the first part, and I guess just for reference, if we want to know what type of log group we're looking at, I'm going to jump back to the architecture here, and we're going to see pretty much is that one in the corner right there, right? So this API is responsible for producing lists of pet results, right? So if we do an adoption, it gives us a list of results back. Put yourself in the shoes of an application owner. Maybe you own this microservice, but we don't necessarily know what's in the logs. And that's common, right? Sometimes you see logs and it's like, I don't know what's in there. Let's take a look at the different log streams. You kind of click around and we see there's a log stream for hotel collectors, we have container logs, but the first step in getting a valuable insight from your log groups is you need to know what's in the logs, right? And a really great tool to do this is we're going to show how you can do this with logs insights. So here we have the standard stock query, right, where we just have, open up any log group and logs insights. This is the query you'll get. And we'll go ahead and just run this and see what we have. And this gives us a pretty good idea, right? It's a limit of 20, but so a sample size of 20, and we can see we have some HTTP, looks like server access logs, right? So you have that space delimiter, tab delimiter format, and then lower down you see some JSON logs in there. Once again, it's not uncommon to have mixed log types in your log group, and we can see that here. However, if we take a look at patterns, this actually gives us a breakdown of the 3 specific patterns we found in this log group. So now I know, instead of having to look at every single log line, I can see the patterns here. And we can select even by event ratio. So now even with pattern, I know what my log group is composed of predominantly. And this is looking at a sample set of 20, but it gives us a pretty good idea. So in this case, we see one of the main API calls is called get top transactions, right? And then from there, we can see log samples, and then of course the tokens, just like we showed in that S3 example. And then if we select the tokens, we can see things like pet ID and pet color and pet type. So it's looking to find get top transactions. That's an API that's happening on our account. This next API that looks like it's being called from this pattern is called list adoptions middleware. And something we see there is result count, right? So once again, put yourself in the place of somebody that owns a results or a list microservice. And I just found out that I have the result count from list APIs right there in my logs. That could be something that could be immediately valuable to me. And then, of course, moving on, we take a look at those HTTP access logs, too. So we see that pattern as well. However, that's based on a result count of 20, right? So what if I wanted to analyze everything? So we hit analyze all records, and you'll see that pattern just got added to the message. So this is that new command where you can just use whenever you want. And now, instead of looking at just 20, we're looking at thousands of log events. So now, within this hour, I can see we had 7,000 log event counts for get top transactions, which make up 78% of my log groups. So that's another big thing you want to think of is what's in the log group, not just the patterns, but like how predominant is that pattern in your log group, and is there anything valuable in that pattern you can use? And in this case, if we go back and we take a look at the result count for that list adoptions middleware, right? Let's take a look at the tokens for list request. So in this case, we can see the token value would be how many list results were returned on that API call, meaning that I can see in some cases we have an upper end of 12 lists being returned. That's about 4%. On the lower end, it's about 1%, or one result being returned, and that's about 6%. So we see that distribution. And this is something you keep in mind, right? Where you're able to see those token values, how evenly they're distributed, but more importantly, since I own the list service, maybe it's something I could want to maybe generate an SLO on, right? Understanding that maybe I would think that having less than 2 results in my list responses is maybe a bad thing. Maybe I would always want to have more things. If I search for something, maybe I want to have more than 2 things being returned. So keep that in mind when we as we move further in the demo. But before we move on, I do want to show off the compare feature. So this is really, really handy when it comes to looking at what changed. Right? So as we looked at the last few slides of trying to identify if something changes within the previous day, the previous week, the previous month, I can just add apply, and then it's going to add a diff command to it. One of the new commands where you can do a diff on the pattern, and then if we rerun this is going to show us, of those existing patterns, how they change from the previous period. So I can see an increase or decrease, or if there's new patterns identified. Think of this in the context of we pushed an application update, or maybe there was something that changed, and we wanted to see the impact of it and how it changed week over week. Being able to compare these 2 time series one over another is incredibly valuable. Alrighty, and I think from there, we are going to move back on to getting some more insights into our logs. So when we think of just looking at a few of those new services we used, right? We looked at pattern detection, anomaly detection. We had the query assist. Being able to use those all in conjunction is very valuable. But I also want to start talking about other ways that we can gain insights from our logs. And it's helpful to kind of bucketize this into 3 distinct parts, right? So first we have detect. Detect, investigate, and enriching logs. So detect's all about, how can we alert, how can we alarm, how can we get something actionable from our logs, and we can do something right away. And that's what we're going to focus on first. So in terms of features that help us do this, I'm going to start with my personal favorite, and what I also would argue is one of the most underrated features of CloudWatch logs, but also one that we launched with, which is metric filters. And you may ask, why is a metric filter important? And the reason for that is because in the world of CloudWatch, if you need to react to something, right? If there's something important and I need to react to it, I need an alarm. And how do I get an alarm? I need a metric. Metric filters allow you to take information from your logs, turn them into metrics, which then in turn allow you to start doing alarming. It also gives you all the cool stuff you get with CloudWatch metrics, right? Metric math, anomaly detection, you can do dashboarding, search expressions, right? It's really, really powerful, but the biggest takeaway here is if there's something important, I really need it, and I want to have it for 15 months of a durable time series that I can alarm on, think of metric filters. And like we said, this is a 300-level session, so there's some stuff you probably already know about metric filters. So let's start with the most basic example. Here we have 2 examples of log data, where we have environment, service, HTTP method, status, and latency. And we have 2 examples of that. And let's say I want to count 200 requests. So my filter would look something like this, right? So I say status needs to equal 200, and if it does, I'll publish to a metric namespace, and I'll count the metric value as 1, right? So we're just counting how many times we see the 200 responses come in. And the resulting metric, I'll have my metric name be 200 responses, and the metric value is 2, because we had two examples, right? Should be hopefully common knowledge. But let's move on to another example of something that's pretty neat that you can do with metric filters that you may have not known about. And this is being able to extract log field values as a metric filter, meaning that instead of just counting 200s or counting the occurrences, I can pull out timing from that log event too. So in this case, not just looking at, all right, we're counting for 200 codes, but then I also want to take the latency request out of that. And all that looks like is this, right? Instead of publishing the metric value of 1, I can publish that field value. Now, what does that give us? And what that gives us is now we have the same metric name, 200 responses, but we have a sample count of 2. Now we have the sum, min, max, average, and all the additional statistical values you have with the CloudWatch metric. And I'm going to show us in the next demo really where that can be super useful. And then lastly, let's talk about what I think is one of the coolest features of metric filters. And this is dimension support. So let's think about, all right, well, we got 200s. Well, what about 400s or 500s or 503s or 401s or 404s? I'd be creating metric filters all day, right? And then you say, it's like, oh, what about different methods, right? So this is where you can use dimension support to create new metrics dynamically. As new fields populate in your logs, new combinations show up in those dimensions, you're going to get new metrics. So in this case, we're going to say, I want the HTTP method and status now to be a dimension filter. So then my filter pattern changes. Instead of me looking for a specific field of text, I just say this field needs to exist. And since I'm using it in my filter, on the bottom there, you can see we're using it as the dimension, right? So in this case, the resulting metrics look like, instead of the metric name being 200 responses, I can just call the metric responses. And now my method is put, and the status is 200, and the second one, our method is get, and the status is 403, right? Those are dimensions. And if you may ask, it's like, okay, why are dimensions important? Is because that's part of what we call a fully qualified metric name. And what that gives you the access to do is you can now start using things like metric insights to query and search, or CloudWatch search expressions to do cross-account searching. So incredibly powerful. But there's also kind of a limit to this, right? How far could we push it, right? What if I said I wanted to do, maybe IP address? Would that be a good dimension? Probably not. And let's talk about why. And the reason for that, and it's really going to come into this next topic, which is contributor insights. And we're going to talk about how metric cardinality grows, so uniqueness of metrics. So in this case, we have our metric being that HTTP response. We have 2 different dimensions. In this case, it would be status code and environment. And then we look at all the unique combinations here, right, of the uniqueness of each field, and then the unique combinations of that is our cardinality. So in our last example, where we're looking at status code and method, those are known fields, right? There's only so many different methods out there, right? Like get, put, post, options, delete, patch, and a couple other, right? In HTTP status codes, there's a few out there, but it's a known bounded list. Let's take something like IP address. And then we start combining that with maybe IP address by request URI or something like that, where the total number of combinations is huge. And in those cases, maybe I only need to be able to look at outliers or something like that. And that's what Contributor Insights is purpose-built to do. So Contributor Insights will look at unique combinations in your log data to pull out top contributors for those combinations of events. Specifically, it can help find outliers and top-end contributors, identify things like impacted users, impacted nodes, and it has out-of-the-box insights for direct service plugin with DynamoDB, and a whole bunch of example rules. But I do feel that this one is a little bit easier to show than tell. So let's go ahead and jump into another demo here. All right, so taking a look at VPC data, right? So in this case, we're looking at a contributor insight rule that shows us source and destination address, right? And what it's going to show us here is bytes out from source and destination. And in this case, what you're looking at, if you kind of scroll up to the top, you're able to see the total number of contributors. So in a 3-hour period, we're looking at 23,000 unique combinations of source and destination IP address. If we move that to 12 hours, that's 47,000 combinations. Now, I'm going to ask, does it make sense to publish 47,000 unique metrics if I really only care about the top 10, 20, 50, or 100? No, it doesn't. And that's where Contributor Insights is purpose-built to do, right? To give you that window into top contributors for these very high cardinality events coming from your logs. And we can see things from VPC flow logs. We can take a look at VPC packets by address. We have built-in integrations for DynamoDB. You could use this for CloudTrail or even your own custom log data. So this is an incredibly powerful tool. And now, before we move on from this, I also want to show what it looks like to be able to edit a rule. because we talked about dynamicness, right, when it comes to metric filters. But now let's take a look at how we can do this with a VPC flow log. And what this uses is, one, cross-account. So this works across account. And then two, more importantly, we can select this by a prefix of log groups. Meaning that, because you ask a question, it's like, OK, this is great, but what happens when we make a new VPC or new VPC flow log show up? Well, with a prefix type pattern, I don't need to look for flow logs being enabled and capture that event to update the rule. We can just use this prefix and it'll capture it dynamically. So if you combine that working cross-account as well as that dynamic nature where you can plug things in based off of a prefix value, it makes this service pretty darn effective. So let's go ahead and pivot to back to our ECS pet list adoption service. So let's talk about metric filters and how they can be valuable. But just as a really quick refresher, I know we looked at this recently, but I want to make sure we're all kind of familiar with the metric patterns we're going to be looking at. So let's take a look at our log groups one more time, just check out these patterns. And here we can see we have, remember, we got get top transactions. That gives us things like pet type, pet ID, and pet color. And if we select those tokens, you can see that the token value is, for pet type, it's bunny, kitten, and puppies. And then pet ID, that's a little bit higher in cardinality because pets have different IDs. Now, if we take a look at our next one, list adoptions middleware, remember we have that result count. And that's something we mentioned earlier that we wanted to build an SLA about, right? Maybe that's something I want to turn into a metric filter. So let's go ahead and take a look at what that does for us. So back in the log group, let's take a look at a few of the metric filters here. And the first one I want to focus on is, and we're going to zoom this in a bit because I think it's important that you can see the patterns. The other stuff we're kind of clicking around, but this stuff is a little bit more important to see the actual pattern here. And what I want to show is this very first one that says HTTP requests. So remember we had a mixed log group, right? We had some stuff in common log format, some stuff in JSON. And before it was really difficult to get a metric filter out of that because you would get stuff that you didn't want to match. Well, as of a couple weeks ago, we launched regular expression support for metric filters. So before with metric filters, it was just JSON expressions and some simple text searching. Now that you have full power of regular expressions, and personally I'm not good at regex, so I got to look it up every time, but let's put yourself in the position where maybe I have XML logs, or maybe I have strings nested in JSON, or something where it's like very specific, or maybe I don't have exact control over the logs, and we kind of just get whatever the applications emit, and sometimes it's not like a really good defined pattern. Regular expression support can help fix that. My ask is that if you take a look at something in your logs where you figure it's like, hey, we can't use it because it's not in JSON, take a look at regex support. It could actually help you out quite a bit. But now let's take a look at this other one where we take a look at requests. So here we have method, pet color, and pet type. So in this case, as long as those fields exist, we can publish those dimensions. Right? So as different methods, different pet types, or different pet colors show up in our logs, we're going to get different metrics for that. And then if we go ahead and take a look at one last one, which is going to be list results. So in this case, right, we wanted to capture that value of that list request. So we filter the method, just show me the list adoptions middleware, and then our metric value is result count. So then you can easily just plug in the field value. So let's take a look at what this looks like from actual metrics. So here we have our metrics, and we can see we have our URI status codes, right? So this is where we use that regular expression support. We have two dimensions, or two metrics that were actually created from one metric filter. In this case, this is the one that we used with method. So now we're looking at 9 different metrics created from a single metric filter. And then you may ask, like, okay, this is great, right? We can build multiple metrics from a single metric filter, but how do I go about rendering this? How do I go about displaying this? How do I go about building a dashboard? Right? If I have a new metric that shows up, how do I get that there? And how we can easily do that is add this to a search request. So we add the search request, and we just hit graph search. And then now we have a dynamically built expression that will evaluate these new metrics as they come in. So not only are we now creating metrics dynamically, but we're rendering them dynamically too, which I feel super, super duper useful. Because then you don't need to look for new metrics. You don't need to be constantly updating dashboards. You have it all right here. Now, one last thing I do want to cover is the list adoptions, right? So we talked about that, and we talked about the list results. So in this case, right, we have the number of list results, and this is where we actually took that value and published it as a metric. And what that shows us, and I really want to highlight here, is the different statistics you have available, right? Because everyone knows, okay, here, what are some of the metric stats, right? You got min, max, sum, average. Like, okay, those are useful, right? But how many people have looked at the expandable metrics? P90, P99. Anyone use those? Yeah, okay. All right, awesome. But let's also take a look at, instead of those, we have another one. So you have things like trim count, trim mean, but one of my new favorites is percentile rank. So in this case, I can take percentile rank and say, show me the percentage of requests that had more than 2 results. So in this case now, at any given period of time, I can then say, at this point in time, 93% of my list results, list requests had more than 2 results in them. Now, if we also have the total count of list results, which we do, if you do count divided by percentage, then I can easily figure out during a given time period how many requests were above or below an SLO that I defined. And we were able to do that simply from just pulling this directly from a metric field. Right? We saw something in our logs that looked useful. We were able to turn that into a metric. And then since we included that telemetry and that timing in it, we're able to then turn that into something valuable for our business. All right. So with that said, I'm going to go ahead and pass it off to Nikhil, who's going to keep us going.
All right, folks. So thank you, Bobby. That demo was really exciting. So let's talk about data protection. So staying on the detect theme, one of the critical logging requirements that our customers were asking for from a data privacy, governance, compliance standpoint was the ability to prevent unauthorized access to inadvertently logged sensitive data, or PII. So folks, this is a really hard and real problem, especially in a world where there's a diversity of log generators that you don't fully have control over, and there are lots of interactions happening between humans and technology-backed support agents like chatbots. So customers were telling us that they were having to build complex custom solutions to be able to protect PII from being accessed by their users. That's why last reInvent, we launched sensitive data protections for CloudWatch logs. And I want to just walk you through a quick illustrative example. So in today's world, lots of people are building GenAI-powered chatbots. So let's look at one which is doing some administrative tasks at a healthcare facility. So a customer is talking to the chatbot, shares their name, their date of birth, their SSN, and the chatbot is logging all of these interactions or all of these prompts to your CloudWatch log. So if you've got CloudWatch log sensitive data protection enabled, you're being able to effortlessly detect and mask this PII data for over 100+ fully managed identifiers, including social security numbers, credit card numbers, dates of birth, and so on. Data is basically detected, like PII is detected at ingest and masked at all egress paths. Additionally, one of the cool things we built with this feature is, like, we knew there were cases where a central compliance officer might want to look at that PII data, like audit it, and really see, like, is this PII? How did it come in? How do I track the source? So one of the cool things we built is the ability for you to actually validate or temporarily unmask PII data if you have the right elevated permissions. So just to complete the story on this one, we have 100+ managed data identifiers across 5+ languages, across 4 different themes: personal, health, financial, credential, and devices. Now that we've learned the best practices to detect issues, let's move over to the investigate theme. And here I want to talk about 2 really popular features that our customers love: Livetail and Log Insights. So let's start with Livetail. So Livetail gives you an interactive, real-time streaming view of your logs, which provides instant insights into issues that are arising during deployments or configuration changes. It offers really fine-grained controls for you to filter the logs based on what you're looking for, as well as highlight attributes of interest. You're looking for error words, or you're looking for certain codes. You can also pause and replay your logs if you want to just quickly look at something that interested you. The animation on the side actually gives you a quick glimpse into what it actually looks like and how the highlighting feature works with 2 customer-defined keywords of interest. The best thing is you can actually seamlessly transition from this view to log insights for your deep dive analysis using deep links. In summary, Livetail is a really powerful detect and investigation tool. Now, we've covered log insights in a little bit of detail across the demo, so I won't go into all the details, but I do want to summarize a few highlights. It's a purpose-built query engine, like I mentioned. We automatically discover log fields for your JSON and AWS vended logs. And these discovered fields makes it really easy for you to know what are the attributes that you can slice and dice on as you troubleshoot your logs. Once you craft the right query, you can actually save it, rerun it for similar analysis in the future. You can export your query results and share it with your teammates to let them know how your investigation is progressing. And importantly enough, what I talked about earlier, last year, we started supporting cross-account log analytics without having to copy data across accounts. So today, we support 9 core commands that make it easy for you to interact with your data. I'm not going to walk through all the commands, but just looking at them, you can see that they're fairly SQL-based, easy to understand. And then through the demo, which Bobby will now show you, he'll quickly show you how these work. So over to you, Bobby.
All right, thank you. Thanks. So let's go ahead and take a quick look at this stuff in action. Okay, so here we're on the Logs Insights console, and I'll zoom it in a bit for us. And what we want to take a look at, let's say logs, LiveTail is really valuable, and like we see a lot of customers use this for services like Lambda, right? You get that near real-time feedback, right? Invoke a function, see the logs, right? You don't need to go to Logstream anymore. You can just get this immediately. However, there's a couple other places where this could be useful. So for example, let's see if we can find this for our VPC flow logs. So we'll keep that example going. We'll select our flow logs, and we'll go ahead and start the query, or start the tail, that is. And hopefully, we should start seeing something soon. Yeah, here we go. And now we can start seeing we have all these different flow logs coming in. And in this case, I've even added a filter pattern of reject. So now I'm only seeing the rejected filtered events. I don't need to look for just, because we have accepts and rejects, and now we can find rejected connections. And then on top of this, I can then even, let's say, let's maybe pull out a specific ENI here. And then we can just copy that in. And then now I can see we have the highlighting for specific ENIs as they're coming in, and then I can just scroll the latest events, and then we can see as new events come in, maybe I'm looking for that, maybe I'm looking for a certain port or a protocol, and then that gets brought up for us dynamically. And lastly, I also want to show a little bit into Logs Insights. So here, I know, and we covered this quite a bit, but I do want to show like a little bit of powerful nature of the tool. And also, this is from a real-world example from a couple weeks ago. So I'm going to walk us through this a little bit line by line, but I'll keep it short. And what we have here is we're looking at event name, request parameters as alias, so we're naming our fields. But the example is a customer wanted to see and attribute KMS costs. They saw KMS costs were high in one case, and they wanted to know where that was coming from and how they could identify who was responsible for it. So in this case, and this is actually, I used Query Helper to put this together for me. So we have the event name, generate data key, so I'm looking for that event. I'm doing a stats count key IRN as requests, naming a field there, but something you may not know is you can use multiple counts in a single stats command. So not am I only being able to count the number of requests, but then I can do some math on that second count because I know how KMS requests are billed. So I can do some math on that, then say, of those requests, multiply it by how we do the billing for KMS, and then that will give me the total cost. And then order it by caller and role. And then we can go ahead and run the query and take a look at a few of the results here. And then here, I'm actually going to have to zoom it out a little bit so we can see everything. But this gives us the key ARN, the role that was called for it, the key alias, in this case, I think it's an S3 alias, and then the number of requests as well as the cost. And then if I were to run this over the period of a day or a month, it would be able to then figure out and determine who those top contributors were pretty easily. And the big point I want to cover here is, take a look at discovered fields, and then check out some of these sample queries that are available. But then a query like this I could easily save for reuse for other people on the team, and they could help then continue to iterate on it. All right, but now with that, let's go ahead and move on to our last topic for the day. And this is going to be enriching logs. And what's important about this is both structured logging, right? So logging in a JSON format, and using EMF, as well as trace injection. So first we're going to cover EMF, or embedded metric format. So this allows you to ingest high cardinality data as logs. So essentially, we're ingesting metric data as logs. And this is really, really helpful for being able to enrich our metric data with logs, with resource environment, or resource information. It's a cost-effective way to collect telemetry info from a very disparate number of resources. So think something like connected cars or car charging stations, right? You can ingest that as a log and then have that as a metric. And we have plenty of getting started libraries for this from Node.js, Python, Java. And odds are you may be using this today and not know it. If you use Container Insights, Lambda Insights, or OpenTelemetry to write metric data, that's all using EMF today. And then lastly, for ingesting and enriching these logs, the last thing I want to cover is adding X-ray traces to your logs. And this is like a really big takeaway here, because what it's going to allow you to do is this lets you take, you inject the trace ID into your logs. And then within your X-ray traces, you say what log group to look at. And what this enables is custom log metric and trace correlation within Service Lens. And this happens for you. And for many services where we can guess the log group, like Lambda and API Gateway, this just works out of the box. But if there's other services, custom components you're building, you can enable custom log metric and trace correlation. So with that, I'm going to go ahead and give it back to Nikhil, who's going to give us some closing thoughts and wrap us up.
Awesome. So let's try and distill the essence of our journey into a few key takeaways. So first, we discussed the importance of observability and how CloudWatch Logs as a Service has evolved over the last decade to become the holistic solution to meet your diverse logging needs. Next, we dived into 3 amazing new logging features we have released this reInvent. So we talked about infrequent access log class, which enables you to make the cost feature trade-offs to be able to consolidate all of your logs in CloudWatch. We then talked about a suite of machine learning capabilities that helps you distill your logs into a few key patterns, allows you to understand what changed, and then be proactively notified when there are anomalous trends in your logs. And finally, we talked about GenAI-powered natural language query generation capabilities for your logs and metrics insights to make it really easy to interact with your data. Finally, we walked through best practices of how to gain insights from your logs, ranging from detecting issues using metric filters, using sensitive data protection, using contributor insights, to investigating them through our tools such as Livetail and Log Insights, and then enriching your logs using structured logging and X-ray trace injection. And folks, we as a team are continuously and tirelessly iterating to make this product the product you want it to be. All right, so I hope you have enjoyed the ride. We'll be around for a little bit to take some questions. And we also encourage you to head over to the observability kiosk in the AWS Village to meet us, as well as other AWS observability experts to answer any questions. We'd really love it if you can take a minute to just fill up the survey. We appreciate your feedback. We want